Hello and welcome to another lesson from Simply PE, this time in the mechanics of breathing and spirometry. And for this particular presentation, just a reminder of the different colour text boxes. You should know by now what each of those instructions mean, so I'll leave that up there for you. But in terms of that AQA syllabus, what do you need to know for GCSE PE? Well, first of all, you need to be able to understand the interaction of the intercostal muscles, the ribs and the diaphragm. You need to know the role of each of these in both inhaling and exhaling. Understand the different volumes on a spirometer trace. And finally, recognise the changes at both rest and in exercise. So we've got plenty to go through, plenty to understand, so stay tuned and let's get going. So first of all, let's look at the mechanics of breathing. So when we think of that term breathing, what we mean by that is the process of which we take in air and we take out the air using our lungs. And ultimately, there are two forms or phases of breathing, both inspiration, which we call inhaling, and that's the taking in of air, and then expiration or exhaling, which is this idea of expelling or taking away, removing air from our lungs. So first and foremost, I want you to look at this question here. I want you to pause your video and see if you can answer it. Take a deep breath, both in and out. What is happening within your body? So hopefully you've unpaused your video there and you've had a deep breath in and deep breath out. What did you notice? So when you breathe in, you should feel your chest be expanding. You should be able to feel that your lungs are taking in that volume, that air, okay, and they are expanding, they are getting bigger, okay. And then when we breathe out, our chest is compressing, it's reducing in size, okay. So there's some visible signs that we can see there in terms of when we breathe in and out in terms of the mechanics of breathing. But we need to go further than that, we need to look deeper than that, so let's do that. So first and foremost, when we look at inhalation, okay, so we're looking at the taking in of air when we inhale. Ultimately, we use different muscles and we also use the diaphragm, which helps us in that inhalation process. So ultimately, the first thing that we need to know is that different muscles contract in order to help us to breathe. And we're going to look more specifically as to which ones, okay, when it comes to exercising. But you can see already on that video above me that the intercostal muscles, which are kind of embedded in between the rib cage, okay, and the ribs, okay, they contract. But the diaphragm also contracts as well, and as it contracts, it flattens. So as the lungs fill up with air and as they increase in size, as you can see on the diagram, the diaphragm also contracts and therefore flattens to increase the size of the chest cavity. So the chest cavity ultimately enlarges. And this contracts, again, the intercostal muscles even further. And ultimately that raises the rib cage outwards, okay, meaning that we've got even a larger capacity for those lungs to expand even further. And ultimately, as the ribs rise, this changes the pressure within our lungs. So we've got a question there. What happens to the air pressure if the chest expands? I want you to pause your video and have a think about that. So the fact that we have the ribs expanding, that chest cavity expanding, means that air pressure inside our lungs are actually reducing because we have a bigger space, a bigger capacity. So as that happens, as we have lower air pressure now in the lungs compared to outside of our body, means that that air can flow into our lungs and we kind of suck in that air into our lungs. So that's basically what happens. So in terms of the next information, all the other stuff that we've just gone through in the previous slide is coming up here now just for you. But just as we talked about the air pressure, just to remind you, the air pressure reduces inside the lungs compared to outside the body. So air is taken in that way. The other reason why I wanted to put this slide on there and this diagram that you can see is because we have now a couple of muscles that help us contract, okay, and help contract in the process of breathing to then take in even more air and increase that cavity or that chest cavity size. Okay, so you've got one word there, okay, sternocleidomastoid. Okay, that's a long word, isn't it? Fortunately, you don't really need to know how to spell that as one of your key words in terms of muscles, but that word may come up in this particular topic. Okay, the sternocleidomastoid is a long, thin muscle which attaches between the neck and the sternum. Okay, so the bone which is found in the middle of your rib cage. Okay, and ultimately that contracts and that helps the chest expand outwards even further. And the same with the pectoral muscles, okay, that we can find here in our chest, the pecs, okay, they contract as well to again help with that enlarging of the chest cavity. Okay, so I just wanted to put that on there for you, just so you know those two key muscles that help with this process. Okay, so let's now look at the exhalation process in terms of when we remove and take that air out of our lungs. So when we breathe out. So the breathing muscles now, when we breathe out, they relax. And it's important to note that the diaphragm now, as it relaxes, it curves and it curves upwards back into that dome shape. Okay, so now our lungs are removing that air, they are starting to deflate, and ultimately that means that diaphragm now relaxes and comes back into its kind of dome shaped. The ribs descend, and that means that the chest volume decreases. And ultimately that means that the air pressure now inside the chest cavity now increases. So if the pressure inside the chest cavity now, when we breathe out, increases compared to outside our body, now the air wants to go back to where the low pressure is. So it's diffusing outwards out of our body and out of our trachea and out through our nose and mouth. So airflow, as it says there, goes from high to low pressure, and that's that process of expelling, removing. I've also made a note there of the two major muscles that we just talked about in the previous slide. If you want to make a note of that, you can as well as part of your understanding. So again, pause your video here. Which muscles help with forcing air out of the body? Can you think of any muscles when you breathe out that might be contracting and helping with you forcing air out of your body? Have a go and see if you can answer that. So if you actually try and do that physically and you try and breathe out as hard as you can, you should start to feel your abdominal muscles within your stomach contracting. They're tensing, okay, they're working hard. So it's actually the abdominals which are also helping you to force that air out of your body. Okay, so the second part of this video now looks at lung volumes, and in particular this spirometer, which is a piece of apparatus designed to measure lung volume. And ultimately, when we think of lung volumes, okay, first and foremost, the way that this piece of apparatus works is when we breathe in into the mouthpiece there that you can see on the diagram, okay, we take oxygen away from the chamber, and the chamber is where you can see the numbers from 4,000 down to 0, okay, showing perhaps how much air has been taken away and put back in. And then breathing out, okay, pushes that marker, that kind of piston, the marker there that you can see within the chamber, okay, back, and the air obviously gets pushed back into the chamber, and ultimately that will impact the marker as to where it goes. So we're starting to think about how much we both breathe in and out. Now again, this question here, why is it important to measure our breathing? So from a sports point of view, from a sports science point of view, why are we looking to measure breathing? So hopefully you've had a bit of time to have a think about the answer to that question. Ultimately, from a sports science point of view, we want to see how efficient our lungs are, so how well they actually function. That's really important from a sports science point of view, because if we're playing in an aerobic capacity, we're playing in an invasive game or a sport that requires us to have sufficient amount of oxygen coming in and removal of carbon dioxide, we need to be able to know and see how efficient our lungs are. And ultimately, the fitter we are, the more efficient our lungs should be, the better they should be performing. So ultimately, it's a good measure of not only how well our lungs are doing, but also a measure of our fitness levels. So let's look into more detail as to what specifically we can measure using the spirometer trace graph, how can we actually see the different lung volumes and what do they actually mean and represent? So first and foremost, we look at tidal volume. So this is the amount of air that enters the lungs during normal inspiration at rest. So how much air are we taking in just through normal breathing in at rest? That's what we mean by the term tidal volume. The same amount will also leave during when we breathe out, during that expiration phase. So when we breathe in and we breathe out, it is pretty much the same amount of air that's going in and out of our lungs at rest. That's what we refer to as tidal volume, and you can see that on the graph here. Okay, so inspiration phase going upwards, and then expiration when we breathe out. Okay, and that was just going at a normal pattern, as you can see there, before we move on to the next bit of the graph. We then look at this next key term, which is called inspiration reserve volume. This is the amount of extra air inspired during a deep breath, okay, above the normal tidal volume. So what I mean by that is how much extra air could we be taking in during our breath in when we take a deep breath. Okay, so the difference, the extra air that we could be taking in, okay, after our normal kind of breathing of our tidal volume here. So you can see this section here is this idea of the amount of extra air that we're taking in. Expiration reserve volume is the amount of extra air we exhale, we remove during a forceful breath out. Okay, again, this is above the normal tidal volume. Okay, so here we can see that the person is breathing just normally. That's their regular tidal volume. You can see on the black line. And then these two symbols, these two markings, represent how much extra air they take in with one extra deep breath, okay, at rest, and one forceful breath out, how much extra air they can remove from a forceful breath. And then finally, here we've got this idea of residual volume. This is the amount of air left in the lungs following maximal expiration. So when we breathe out, and if you try to breathe out as much air as you can in one breath, and if you try and do that, you can try and do that as a quick kind of experiment yourself, you will have some air left in the lungs, okay, following your one forceful breath out. Okay, so that's what we mean by this term residual volume. Here on the left hand side you can see the total lung capacity, okay, which represents how much air can be both how much air can basically enter your lungs and can be released. Okay, so there it's that total capacity. So this question here, what happens to our tidal volume and breathing rate during exercise and why? So we can see here on this trace graph that in this section here, this is the person at a normal rest. Okay, so pause your video here, have a think about what's going to happen to our tidal volume and our breathing rate when we exercise. So hopefully you've unpaused your video, you've had a think about that. And you've looked at the graph to maybe help you a little bit, but you've also just looked at the key terms. That can also help you as well. When we think of tidal volume, just have a think about what that word was again. We're talking about the amount of air that comes into our lungs in a normal inspiration at rest. Okay, tidal volume, what's going to happen when we exercise? What happens to our breathing anyway? We breathe deeper. So if we breathe deeper, we are actually going to be putting in more air into our lungs. Okay, so ultimately our tidal volume should increase because we need that air, we need that oxygen to go to the working muscles because we are exercising and our muscles require that energy. What happens to the breathing rate? Well, our breathing rate will also increase. When you start exercising, you start running, you start sprinting, you start to breathe quicker, deeper, but also quicker. Okay, so ultimately, That happens, the tidal volume increases, the breathing rate increases during exercise because we need to get more oxygen to the working muscles. Okay, so to finish the lesson, I've got two exam practice questions. This first one is a differentiated one, a little bit easier to answer, and the second one is maybe a bit more difficult. So it's up to you which one you want to do, or you might want to try both. So again, you can see the trace graph here, which represents, and you can actually see some of it is labeled. Okay, so here we've got the rest phase, okay, where we can see the tidal volume is a little bit lower, in between sort of 2, just above 2 and close to 3 litres. Okay, and then we have the exercise happening and the tidal volume is starting to increase. Okay, so pause your video here, see if you can answer this question. Identify the lung volumes labelled X and Y. So all you're trying to do here is label that graph. Okay, so hopefully you've come out with an answer. You might have drawn the graph to help you with your understanding as well. Okay, but ultimately X represents that inspiration reserve volume and Y represents the expiration reserve volume. So you should be able to see here that inspiration is that extra inhaling of how much extra air can we get in above the tidal volume of one breath in, and that's the expiration. How much extra air can we breathe out in one forceful breath? Okay, so let's look at the second part of this question. So it's exactly the same diagram, but this question now is saying, using the information in the diagram above, suggest a sporting activity that may be being performed. Justify your answer. So it's not asking you to label the diagram now, it's asking you to interpret it, to look at it and decide what type of activity you think is being performed. So have a look at that and decide, so from this rest phase here, from the tidal volume to the exercise itself, what type of sport is perhaps being performed or activity. Okay, so hopefully you've come up with an answer, and unlike where some students will get confused by thinking about interval training, for example, we might see this same kind of pattern in interval training. The exercise that you can see here, what's happening to the tidal volume is that, yes, it is increasing when we exercise, but it's remaining steady and it's remaining constant. So it's not changing at all in terms of that tidal volume of when we exercise. So that might give you a clue in terms of what type of activity might be being performed here, if it's a steady sort of exercise. So for the AO2 section of this answer, we're looking at coming maybe 3 marks, you could have mentioned a steady kind of activity, a steady rate of things like jogging, cycling, perhaps rowing, or even a marathon run. Okay, so any sort of activity where there's a steady pace going on involved would have got you that mark for that. For the AO3, okay, this is now a bit more of the explanation and evaluation aspect. You could have mentioned this named activity is a steady state, and you can tell by that because it's repetitive in nature. The tidal volume is not increasing and decreasing, and there's no changes in levels at all. It's remaining constant. The breathing rate will largely remain the same for this activity, okay, because ultimately, although our breathing rate will increase when we first start exercising, when we're in a steady activity, okay, and we're actually just performing a jog or we're performing a long distance row, eventually our breathing rate kind of plateaus and it stays steadily the same. It also says here, the final point, oxygen demand will not require a significant increase in breathing for that particular activity. Okay, so ultimately, okay, if we're performing something steadily, okay, our body starts to adapt and the oxygen demand isn't particularly high because we've adapted, we've changed back into it. So I'm hoping some of those answers there will have helped you, okay? And finally, from a teaching and learning strategy point of view, key things is to make sure that you get students to practice these questions to increase their confidence in looking at graphs and being able to interpret what is going on, so that have as much practice with this. Okay, this topic shouldn't be too difficult, but students sometimes struggle with this a little bit because they're a little bit unconfident with so many different keywords and what each keyword means. But the exam board can't ask too much in regards to this, other than the fact that it might be, for example, labeling graphs, interpreting some of those graphs, and thinking about what type of exercise, what's maybe happening in the graphs. So get your students used to this. Also, try and use sports science videos to help with explanations of key terms, especially in the lung volumes, and to help them increase their knowledge, and also start to embed this idea of the structure of the heart and how the heart works and how the respiratory system and the cardiac system, how they kind of interrelate with each other. Best of luck with the video. Thanks for listening. Take care.